Cause I'm taking the world, you'll see. They'll be calling me, they'll be calling me royalty. Best to give me a loyalty. Cause I'm taking the world, you'll see. They'll be calling me, they'll be calling me royalty.
Panera favorites are hot and ready to serve for dinner. Taste our creamy mac and cheese served in a crispy bread bowl. Or the classic bacon turkey Bravo featuring our signature sauce. How about our new mouth-watering Chipotle chicken and bacon flatbread pizza? These and other favorites are waiting for you. Order dinner tonight for delivery or pickup. Only at Panera. Availability and pricing may vary.
Want to hear something amazing? Discover matches all the cash back you earn on your credit card at the end of your first year, automatically, dollar for dollar, with no limit on how much you can earn. Extra cash? Come on, how amazing is that? In fact, it's even more amazing when you realize all the places where Discover is accepted. 99% of places in the U.S. that take credit cards. So when it comes to Discover, get used to hearing yes more often. Learn more at discover.com/yes. 2021 Nielsen Report. Limitations apply.
Let's be real. Mopping is a hassle. You have to fill the bucket, pushing a wet, heavy mop around, then cleaning the mop when you're done so it doesn't grow bacteria. A hassle on top of a hassle. Try Swiffer WetJet. With Swiffer WetJet, you start with a fresh pad and cleaning solution every time. And when you're done, you just toss the pad. Swiffer WetJet, the faster, easier, cleaner way to clean your floors.
Hey folks, how's everybody doing today? Happy Monday. Welcome on back. Hope you had a good Memorial Day. Alrighty, we'll back that up so we can do that one later. Alright, we got a couple things on tap today. First we'll talk about Project 1. I think all of you got it submitted. The numbers looked pretty good. And then we'll get into Chapter 4, which is essentially two different pieces here. It's loops and then files. And then we'll talk about Project 2, which will be due in 2 weeks from tonight. Uncle Bill. Welcome on in. Alright, so let me fire up NetBeans here, and we'll take a look at that first project. Yeah, I've thought about having it on in the background, like behind the scenes, but I don't know. It's the mic picks it up sometimes, and then you don't catch everything, and it gets a little awkward because I haven't figured out my sound. Yeah, 29 submissions. That's good. That's good. All right, this was our semester calculator. Okay, so we're going to write a program, helps them calculate how many more semesters of school they have to complete their degree, along with the total cost of the credits. And we got a little rubric here for 8 points. We'll follow along. Make sure this works out well. As soon as I get my NetBeans to load here. Hello? Okay, is he causing trouble? Thanks. Here, Marlon. Come on, baby. Come on. Oh, he looks mad that he got kicked out of downstairs. Sorry, buddy. He's reached the teenage years in Cap already. Within a week or so of the submission date, Silver Dart, so probably before next class is the goal. Although you had quizzes that were due on the 24th, and I totally forgot with Memorial Day that had been a week, so I'll be working on those quizzes as well. I know those are a little bit behind, sorry. Let me close this out. Need this one. We can close all of them. There we go. We'll start up a new project. He's a little grumpy at the moment. He did not want to come over here. But I'll catch him in a minute. I'm sure he'll come and hang out. Alright, so I'm going to put this in my 1500 folder. And this is Project 1. Alright, so if we're going to be using user input, right, and like prompting the user for things and getting them to type stuff in, we need to use that scanner object. Right, so we'll make a scanner. There's a new scanner, given system.in. Again, don't worry too much about it, just copy it. It's no big deal. Oh, 2 ends, right? There we go. Yep, and then we want to import java.util.scanner. And it adds a little import line. Again, you can type that line if you want, but I'm not a fan of typing things I don't need to. Whew, yes, 6 streams worth of music would be rough, Uncle Bill. I don't know how you keep any of that volume straight. We'll ask what their name is, or, you know, like, welcome to my amazing calculator, or what, semester planning tool, I don't know, college planning tool. And then we can ask them, what's your name? What's your name? And we're going to store their name, right? That's like a new string. I'm going to call it name. You can call it anything you want, but name is nice and, nice and descriptive. Use keyboard.nextLine. Next line will get the input, whatever they type in, and it'll store it here as name. We're good to go. Now we can use name in the rest of these prompts, right? So we need to say, ask their name, how many total credits are required to complete their degree. So we can say name, right? We'll give their name, and then like a comma and a space here for the rest of the message. So if I put in Eric, it'll say Eric, comma. Any credits are required for your degree. Or maybe how many total credits are required for your degree? Sure. Again, it's getting a little bit long, but my font's kind of large, so I'm not too worried about it here. In general, you shouldn't have to scroll left or right to see anything. Okay, and then now this needs to be a numeric value, because if we're going to do arithmetic, it needs to be an integer. So this will be an int total credits required. Is going to be, and there's 2 ways to do this. Again, you could say keyboard.nextInt, but I always recommend against using nextInt. Always recommend against that, because what's going to happen is when you use this, the next time you go to use next line, the enter key is still there, right? So they type in a number and they hit enter. The scanner thing will only get the numbers they typed in, and it will leave that enter key on the buffer. The next time you use next line, it'll just automatically say, oh, I see an enter key there, grabbed it, and you just have an enter key. So instead of just keyboard.nextInt, what I usually do is we'll say next line, and we're going to hand that to the integer conversion. We say integer.parseInt. Parse is our fancy word for convert. Right, so integer.parseInt of keyboard.nextLine. What am I missing here? My parentheses here. So I ended the parentheses for next line, but I did not end the parenthesis for parseInt. There we go. One more parenthesis and it's happy. Okay, so now I have the total credits required. We'll ask how many credits they have completed. Again, similar thing here. So I'm just going to copy paste these two. How many credits have you completed? And then this will be like credits completed. Will be integer.parseInt given the next line. Okay, and then we'll ask, well, we'll figure out how many credits are remaining. Sure. So that'll be an integer result. No, it's no problem at all. It's just if you want to then go get some string input, it's going to cause trouble later on. So there's nothing wrong with using nextInt. It's just it can cause trouble. So I typically recommend against it. No, the fan. All the dates are in GitHub, so just go ahead and submit now. It's still open for submissions, and I'll take a look when I see it. And I'll say, oh, it came in late, and I'll look at the dates, and you'll be fine. No big deal. All right, so then we'll have an int credits remaining is the total credits required, right, minus the credits completed. So whatever value is this, minus whatever value is this, is how many credits they have left. Right, that's why we have a nice variable for it here. It's the credits remaining. Then we'll ask how many credits they take in a typical semester. So again, we'll do something like this. We'll prompt something and get some input. So how many credits you take each semester? And again, I know that's not exactly an even number, but we're just going to say on average or whatever, right? This is what average credits per semester. Okay, again, integer parseInt, given whatever they type in, keyboard.nextLine. Okay, and then the cost per credit. Okay, so again, we'll just paste that in. So how much does each credit cost? And then we'll have cost per credit. Okay, again, just using nice variable names here with this camel casing. So starts with lowercase, then every next word is uppercased. Right? Why are these? That's fine. It's warning me that I never use it, but that's okay. We'll use it in just a minute. It's being too helpful. Then we'll calculate how many semesters are required to complete their degree and total cost of the remaining credits. Now here's where we looked at needing to round up. Remember using the math.ceil to round up to the next integer value, because you can't take half a semester's worth of classes. So if on average you take 12 credits per semester, but you're only going to need like 3 semesters of 12 and then 1 semester of 9, you can't take 3/4 of a semester, right? You still have to take that entire semester. You'll just take less classes. Okay, so we'll have an integer value for semesters remaining. Is going to be math.ceil, right? And what we're going to round then, like this math.ceil is going to be my, oh, I probably need to know, right? This is, oh, you know, we can just do the division right here. So it's my credits remaining divided by my average credits per semester. And right now it's warning me, it's saying, hey, this doesn't work. Incompatible types. Possible lossy conversion from double to int. Because remember, math.ceil gives you back a double. I'm saying, hey, I want this as an integer. So what we can do is we can say, hey, I really want this as an integer. This is the casting something as an integer. And this is actually, I know there's a problem with this. We're going to look at it in just a minute. So don't worry, I know there's a problem here. Okay, so that's the number of semesters remaining, and then the total cost remaining, right, is just my cost per credit times credits remaining. We can tell them you need to take, and then we'll just append in here, right, you can do that string concatenation. Take a string, we use the plus sign, it's not adding, it's concatenation. more semesters, your remaining cost, or what, the cost, I don't know, sure. Cost of the remaining credits is, and put in the $sign there, and then we'll append in there. Now this is my cost per credit times my credits remaining. Okay, all right, it's getting a little long there again. I can bump some of these down if I need to. I'll be able to see everything. Okay, so let's try it. Let's go ahead and run. Okay, Eric, how many total credits are you required for your degree? We'll just say 127, sure. And we'll say, how about, what, 45. Okay, and if we take 15 per semester, this should be some easy math. So it'll be 45, 50, 60, 75, 90, 105, 120, plus another semester. Right? What is it would show semesters? So you can't take 2.66666 semesters. It needs to be rounded. Right? This is calculate the total number of remaining semesters needs to be a whole number. It's right out of the rubric here. Okay, that's why you do a self-assessment using the rubric. Okay, so if we take 15, it should tell me I need 6 more semesters. And we'll say it's $100 a credit, but it says 5 semesters. Oh, crap. That's not right. For $8,200. Oof. But that's, you know, it's still a bunch of credits left over there, right? Well, what's happening? Remember, when you take an integer divided by an integer, you get an integer result. Right? If you want it to not be an integer result, one or the other or both need to be a double. So I'm going to change this to be, this one we'll just say is a double. I know it's an integer number, but if we store it as a double, right, then in this arithmetic here, we'll use a double, and if one of the two operands is a double, the whole thing's a double, then we can round it with math seal, then we can turn it back into an integer to save it as semesters remaining. No, I mean, so when you submit, you can just say, hey, like for item 1, points, item 2, points, item 3, points, or like copy paste it in. So you just give the URL and then you can just copy paste. Or if you just say, hey, yeah, I got all 8, sure. I mean, it's my last chance to make you look at the rubric. Okay, so if one of these is a double, now let's try it again here. We'll say Eric, say 127, we'll say I've done 45 of them, we'll say 15 each semester, say $100. Now it says 6 more semesters. That's looking good. And cost, ooh, now I get the 0.0 in here. Because remember, this is now a double as well. Because right here, when I did the arithmetic, it's giving me a double result. Excuse me. Let's check and see. So I asked for the user for the name. I use the user's name in all the following prompts. Ask the total of required credits. Credits already completed. Ask for the cost per credit. Ask how many credits are taken per semester. Calculate the total number of remaining semesters as a whole number. And calculate the total cost of remaining credits. What do you think? Do we hit all the correct? Everything good here? It looks like it did round up. Right, and maybe it's worth trying here. Sure, let's do it one more time. Run it again. Remember, any code you write is worth testing. You want to make sure that it works as it's supposed to. So say Eric, we'll say 120, and I'll say I've completed 105. And if I take 15 per semester, that means I should have 1 semester left. Right, to make sure it doesn't add additional, right? If the arithmetic works out to be exactly a whole number, math.seal should leave it alone because it is already a whole number. There's nothing to round if you're exactly 1. Okay? And for $1,500 more. Right, questions, thoughts, concerns about Project 1? Again, just getting in there, using all the stuff from Chapter 2. Nothing in here from Chapter 3. No if statements, no else statements. Right? None of those conditional checks. It's just all straight. You run the code from the top to the bottom, and every line of code will run. So, like, submit the URL. and a self-assessment using the rubric. So give me a second. Let me go back here. Let me log in as my student account real quick. Let's see, how do I do that? Yeah, I don't do this very often. Impersonate, there we go. There, all right, I'm logged in as the student me. Oops, let's throw it over here. So I would go to assignments, and I would go to project 1, not submitted. And I see the rubric right here, so I can just either copy them all out and say, hey, 1 out of 1, or, for item 1, 1 out of 1. That, I don't know. Any way you want to tell me that you got the point for it, it's cool, right? If you want to number them, great. If you want to just copy paste them in, great. And along with the URL here, you just submit all that. That's what I was expecting. And again, if you didn't do the self-assessment, there's no points for it in the rubric, right? But that's okay. So, I mean, it's my last chance to say, please look at this rubric that I wrote. Make sure you did these things, because I often get questions like, hey, I don't know how I did on it. And I'll say, well, if you did the thing in the rubric, you'll get the point. Yeah, the name should be in every question, right? Every question. Here. Yep, so these ones aren't questions. I guess we could add their names there, sure. So a prompt is typically what we'll call like when you're asking them to enter something. Right? These last ones here aren't questions, right? Like you need to take more semesters. So you could use their name if you wanted. Cool. Yeah, no worry, no worry. So I think I've got their name in all the prompts, so I'm feeling pretty good about everything here. And I'm good to submit. So I can take it back off of the student view here. Let's see. Like a button, yeah, stop impersonating. There we go. All right, cool. Now, 30 submissions, perfect. All right. Don't forget, you do have the next quiz due 11:59 p.m. tonight for Chapter 3. I know it's been a little while. Excuse me, hopefully you got a chance to get that one in. All right, due tonight, 11:59 p.m. I typically have the quizzes due 11:59 p.m. just so I get one last chance to remind you to do it. But all the projects are due by 6, so I can go over the solution in class. So sorry if the change in times is confusing, but trying to give a little bit of extra grace time here for these quizzes. And I know those can be easy to forget. So after tonight, I'll post a quiz for Chapter 4. It'll be due next week, right? And on and on and on. We'll just keep going with that general flow of things as we go. Okay? All right, it's cool. So let me open up my GitHub client here. And I'll go find the 1500 repository in a second, and it should see a bunch of new files. If it ever opens. There it goes. So let's find 1500. There you go, and it should say, hey, there's a bunch of new stuff. Look at that, new stuff. Here's my project1.java. Give it a commit summary, like project 1, commit, and push. All right, so mine's out there in the course repository for reference. If you're so bored and want to go compare, you're welcome to do that. All right, any other questions, thoughts, concerns before we move on to Chapter 4? We got lots of time, so I don't think we need a break yet. We'll work on some loops and things, and then we'll move into, then we'll take a break and we'll come back and finish up Chapter 4. I'll start up a new project, call this one Chapter 4. Cool. I'll just close project 1. I don't think we need that open. Really got to just get rid of that template. Well, so that point on the rubric there, you would not get points for, or maybe partial points. Maybe half a point because it's not a whole number. Yep. Yeah, because 2.6 semesters is meaningless, right? It's either 2 semesters or 3 semesters. Yep. So probably just half a point. Not too big of a deal. All right, so we're going to talk all about loops. There's a couple kinds of loops. We'll talk about while loops, do while loops, for loops, things that you can use them for. We'll look at break and continue, which are fantastic, but I don't like them myself just because they confuse me easily. Looking at different, how do we know which loop we should use? And we'll look at file input and output, and we'll look at random number generation. We got a lot of things in this chapter, and it goes by relatively quick. But this actually gives us a lot more functionality here, which is really cool once we have this ability here. Okay? So the first thing, before we actually do loops, we're looking at two special operators here in Java. So if you have an int number, and we say maybe it's 10, right? Number's 10. We can change number, right? A variable can hold different values, but only one at a time. So if I want to change number, I could say, hey, number, you're now 42. Or I could do arithmetic. I could say number equals, how about number plus 10? And I'll add 10 to it. Or number plus equals 10. Now, this is the combined assignment operator. These are the exact same things here. If you're going to use the number and add to it and assign it right back on top of itself, this is the combined assignment operator. It does the operator and then assigns. Very cool. So often, if you just want to increase by 1 here, programmers who are lazy, like all good programmers, we want to be more efficient, said, well, this is a lot of things to type for just adding 1. And they said, okay, well, let me give you a shortcut. Let's say number plus plus. So number plus plus is the same as number plus equals 1. Right? This is the increment operator. Increment operator adds 1. Okay, because obviously hitting plus plus is better than hitting plus equals 1. You've saved 1 character stroke. Sure, why not? Now, there's also the increment operator that you can do this way, plus plus number. This is a prefix increment. Now, I will almost never use these. Honestly, it's just another thing that confuses me. Like, if you have to do it this way, you're probably trying to be too fancy for your own good. So what happens here is number is used, and then 1 is added to it. In here, 1 is added to number, and then it's used. Now, in our case, we're not doing anything with number. But I could say, hey, let me print out number. So the current value of number is, and then we'll add in here number. Okay, so we'll see what number is. And then if I say right here, number plus plus, and if here I say plus plus number. So whatever number is here, right, which should be 42 plus 10, 52, plus 10, 62, plus 1, 63, plus 1, 64, plus 1, 65. So we should get 65. And then it's still going to spit out 65 because the postfix operator, this is a postfix here, will use number, then it will add to it. So I'm going to say 65, 65. It will then turn to 66 at the end of this. Then right here, it's going to add 1 to 66 and then use number. So it's going to say 65, 65, 67. It's crazy like that. Again, I find prefix confusing. So it's not a common thing that I'll ever do. But it happens before you use the number. Okay? So what we could do is we could say, let's say int number of guesses equals 0. And we'll say if number of guesses plus plus is less than 3. Again, this is just awkward, but sure, you can do that. So guess a number, and maybe we'll use a scanner. Keyboard equals a new scanner, given system.in. And we'll have, I don't know, let's import scanner, sure. We'll say int guess is equal to, now again, integer.parseInt, parseInt, given keyboard.nextLine. Okay, so they can guess. So now I'll have a guess. Then I want to say, hey, did they get it right? Right, we can do that, sure. Probably doesn't have to happen inside the if block, but well, we can do it inside the if block, right? You can put an if inside of an if. So if guess equals 42, you got it right. Right? Else if guess is less than 42, we'll spit out too small or too low, right? And if it's not equals and it's not less than, it's gotta be too high, right? Remember, work smarter, not harder. So if it's not equal and it's not less than, it has to be bigger than. Okay? And then we'll do it again. Boom. Boom. I can do it again and again and again here, as many times as I want. So here, let's do this. Let's have another here. So we'll have an int for max guesses. We'll start off at 3. So this is better. So this way, instead of having a number in here every time, I have a variable here. Max guesses, max guesses, max guesses. Okay, so as long as your number of guesses is less than, or number of guesses plus plus is less than the max, you get a guess. So let's try it. So guess a number. How about 10? Well, 10's too low. How about 20? 20's too low. How about 30? 30's too low. We're done. We're finished. So number of guesses plus plus, the operator, remember, arithmetic happens before greater than less than signs. Remember our order of operations here? So it's adding 1 to it, then comparing it. So I only got 3 guesses. Right? But what if I wanted to have more guesses? Right? Well, I could copy paste all of that and have more guesses. Ugh, that sounds really ugly. But we could do this sort of thing, right? And let's check too high, right? 50's too high, 30's too low. How about 42? We got it right. Again, I know what the number is. It's not super interesting here. Okay, but we can use increment. The same thing you can do is you can use decrement. So you can say number minus minus. That's the decrement operator. Right? It decreases it by 1. And you can do it prefix or postfix. Either way is perfectly fine. Okay? This part makes sense. This prefix, postfix, increment, decrement is just shorthand. Like anything that we do a lot in programming, there's probably a shortcut for. Because the people who write the code that we use to program computers are also developers themselves, and they're lazy. And they love shortcuts. We all love our shortcuts. Okay, so again, this is sort of silly to have this in here so many times. Right, but then if I wanted to change max guesses, maybe I could give me 5 guesses or something. Again, it's not great, but it's okay. So here's what we can do now. So anytime you have the same code more than once, you should probably feel bad about yourself. Because now we're going to learn the better way to do this. So instead of this being an if statement here, we can say while here. And then the rest of these get to go away. Because while is a loop. It says start here. If this is true, run this code block, just like an if statement. If it's true, you run everything inside the parentheses. So same with while. If this is true, run everything inside the parentheses. What's different about a while loop is that when it's done here, it comes back up to the evaluation. It says, oh, hey, if this is true, do it again. If it's true, do it again. Run it all. If it's true, do it again. If it's true, do it again. Over and over and over and over and over and over again. So now let's try and guess. Right, how about 10 and 20 and 30? Uh-oh, I ran out of guesses. Right, this was no longer true. If it's not true, it doesn't run, just like an if statement. Right, so it only runs if this is true. So a while loop is considered a pre-test loop because it's tested before you run the loop. So if this is not true, if I screwed this up and said like max guesses was 0 or number of guesses was not less than, it would never run at all. So there's no guarantee that a while loop will run, right? Because it's a pretest loop. If it's not true, it doesn't run. If it is true, it does run. Great. So what you have to do is you have to be careful though with a while loop that you don't end up in an infinite loop. So if I forgot to change the value that I'm checking here, so if I wasn't using this increment operator, if I just said, hey, number of guesses is less than, guess what I have here? I have an infinite loop because this number of guesses never changes. 10, 20, 30, 40, 50, 60, 70, 100, 10, 10, 40, 44, 42, 42, 42, over and over and over and over and over and over. It never stops. So it's really important when you're using a loop that you're changing these values here to make it possible to make it true. Now, maybe I'm just a really bad guesser, and it took me 100 guesses because I guessed like 1, 2, 3, 4, 5, 6. You know, the way that you annoy your kids when they're like, guess a number, and you just guess one number at a time. Sure. But if we're incrementing it here, great. The other thing you could do is you could have that statement lower down, right? You could say, hey, number of guesses plus plus inside the loop. Sure, perfectly fine. No big deal, right? As long as you're changing it, we're okay. So but now what's fun though, we can say, hey, how about an int max guesses? Here, let's actually move this down, sorry. Max guesses should be integer parts int of keyboard next line. How many guesses do you want? Another parenthesis there. There we go. So we'll ask them, hey, how many guesses do you want to take? Sure, so if you want to give yourself 100 guesses, you get 100 guesses. If you want to give yourself 2 guesses, you get 2 guesses. Right, so we'll do 50 and 20. We got 2 guesses, we're done. Game over. Is that kind of cool? So we can control this loop here by asking them, hey, how many do you want? Okay, so just some fun things, right? We can say while, or we'll do this, int, I don't know, x equals 10, while x is greater than or equal to 0. And let's throw, yeah, that's fine. We'll just put that in here. Print out x, and then we'll take x minus minus. Or really, if that's all we're doing, we can put it right in here. We can print out x minus minus. So 1 guess, we'll guess 42, and when we get 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. On down. Once it becomes 0, and then we subtract with -1. -1 is not greater than or equal to 0. Big dog, I don't know what it means, too ratchet. I don't know. If you like Vim, go for it. I am not a fan of Vim. You know, as much as I love my keyboard shortcuts, I've never really gotten into the Vim editor because I do love my mouse. But that's okay. If you love keeping your hands on the keyboard and you hate the mouse, learn Vim. Go for it. It's a fantastic tool. People who are good at it are really, really fast at it too, which is really cool. Sure. All right. How do you feel about while loop so far? So if it's true, it runs. A posture check. Thank you so much. Let me get on my little backboard here. You can see me slouching in, can't you? I'm gonna have to bring this to campus. Ooh, today was the day we were supposed to hear about in-person classes or not. Did we ever hear? I'm really curious now. Now that somebody mentioned it. I don't know, I'm the one that mentioned it. Oops. So do we have anything? They were supposed to say by June 7th. Latest news. Nothing. Seriously? Seriously nothing? That's crazy. Scanner. So Scanner is built into the Java util library here, and it's used for using keyboard input and output. No, not even output, only input, right? And you can actually do a couple other things with Scanner. We're going to look at that later today. But if you give it system in, it can get things that people type at the console. So remember, plus says, give me the number and add 1. So it's changing the value of number of guesses. So number of guesses starts at 0. If we never change number of guesses, we have an infinite loop. So by adding the plus here, we're saying, hey, add 1 to the number. And it's happening before the less than is evaluated because of the order of operations. Right? It could be inside the loop as well, right? As long as you're updating whatever you're checking here in the loop, good, you're good to go. Oh, we do have more coffee. Hooray. I thought I was out. All right, now I'm out. That's sad. Out of coffee. We'll have to stop for beverages soon. All right. Some really cool things you can do with a do or with a while loop. Right? We can ask the user for a number. We'll say, I don't know, this is, oh, I should ask them, right? Enter a number 1 through 10. And then we can have the number. Int number, or I don't know, this is user's number is, again, the integer.parseInt. I'm just going to go copy paste it because I don't like to type things a lot. And now we'll say while user's number is less than 1 or user's number is more than 10. So if they entered a number that's less than 1 or more than 10, I want to ask them again. But this time I don't need to tell Java it's an int already. Right? So this is called a validation loop. So they're stuck in this loop until they give me a valid value, which I have defined as greater than or equal to 1 and less than or equal to 10. So what is here is invalid. Less than 1 is invalid, or more than 10 is invalid. Right? So the ors and ands here are a little tricky, so it takes a little bit of time to think about. So remember, with an or, if either one of these is true, the whole thing is true. And if this is true, the loop will run. So if they enter a number like 0, 0 is less than 1, true. 0 is not more than 10, false. But true or false, the whole thing becomes true. So the loop runs again. So again, I'm feeling bad about myself because I have the same code in here twice. So my trick for this here then is I'm going to get rid of this output here, and I'm going to start it at a number. So start it at an invalid number. So the loop runs. Right? If you give it something that is not, or I'm sorry, something that makes this true, the loop will run, and then they'll enter it. This way I don't have to prompt them, save it, and then check, prompt them, save it again. Right? This is my shortcut here for being lazy. So start at something that's invalid. That's an invalid number, so the loop runs. The loop will run, they'll give me a number, and then when we're done, now I have a user's number. Okay, this is forcing them then to make sure they're giving me a valid input. Right? So when this one runs, let's give them some numbers. Sure. So number 1 is 10, 0. How about 11? How about 20? 50? 5? As soon as I give them a number that's valid, this is no longer true. Right? So when we get to the ending curly brace, it comes back and evaluates and says, hey, is it true? If it is true, the loop runs again. If it's not true, so remember with an or, both of these must be false. So is 5 less than 1? No. False. And is 5 more than 10? No. False. So false or false, the whole thing is false. The while loop doesn't run. Just like an if statement, it doesn't run. Okay, how's that? That one feel okay? Now there's another kind of loop, very similar. It's called a do-while loop. And a do-while loop is a post-test loop, which means the loop will run at least one time. Then it will check to see if the while statement is true. And I actually hate do loops. I despise them for one stupid reason. I'll show you here. We did the exact same thing here. But the cool thing about a do loop is you don't need to give user's number an invalid value. We'll say do this, and then I say while semicolon. It's can't call it user's number. I don't know, do loop. Sure. User's number do loop. User's number do loop. User's number do loop. User's number do loop. So I can just say, hey, I need an integer, call this. You don't have to worry about a valid or invalid value because the loop will run at least once. The reason why I hate this is you put while and then a semicolon. This semicolon drives me absolutely nuts because it's totally weird, right? A regular while loop doesn't have a semicolon. An if statement doesn't have a semicolon. The other loop doesn't have a semicolon. But for some reason, do needs a semicolon after the while. I don't know. I hate it. I absolutely hate it. So I will avoid using do loops just because I don't want to have to put in that semicolon, right? And again, essentially, if you just give it something that's invalid, you know the while loop will run, rather than making it run once as a do loop, which is guaranteed to run once. Okay, but if you like them, go for it. Perfectly fine. I don't, all good for you. So I'll tell you a story. I love telling stories. Back when I was an undergrad, I had someone who I was pretty good at it. I had some previous experience thanks to my older brother, and someone I was actually, I don't think they were in the same class as me. I think they were taking the class the semester after me, but somehow they wanted to find a tutor. So I was like, oh, sure, I'll tutor you. And they didn't go through the Academic Sports Center for reasons. I don't remember why. I think it was scheduling reasons. Like their hours weren't good or something like that. So anyway, I was a private tutor, and she had this statement here. You can put a semicolon here. What happens if you put a semicolon here is that the while loop thinks this is a statement, and just like an if statement, remember, you don't technically need curly braces. They're not required. They're just super good, right? It's the best practice to put curly braces in, right? So this is technically fine, and it's going to be an infinite loop because the only thing the while loop does is an empty statement. But Java says, oh, sure, you want a while loop and to do nothing? Go for it. I am happy to do a while loop for you. And then we get stuck into this infinite loop. And it took me like an hour of looking at to, like, I didn't know why it was stuck. Didn't know why it was stuck. Didn't know why it was stuck. I was so confused why it was stuck. It's stuck. It says it's running. I can type stuff in. It's not doing anything. It is still running this while loop here. We're stuck, folks. We are in an infinite loop. So another reason why I hate do loops, because you have to put a semicolon here in this while, but if you put a semicolon in this while, you just broke it. Okay? Semicolon. Like I can leave code comments, right? Probably not a very useful comment, I'm sorry. So, but do loops are a post-test loop. It will run at least one time, rather than the pre-test while loop. 0, you're saying the confusion continues because I get confused a lot, or is this confusing for you because like sometimes you need semicolons and sometimes you don't? Yeah, if something's not making sense, please shout it out, let me know. I'm happy to talk about it again and again and again and again until we all go nuts. Because it's all brand new stuff, right? The idea is that we're looking at this toolkit, essentially, of things you can do in code. And we started off with some really basics, and then we're adding to our toolkit as we go. And we don't stop adding all semester long. Right? We just keep on adding tools. A lot like a math class, right? You learn basic arithmetic. It's a tool. And then you learn, you can do algebra. Right? You can do trigonometry. They're just fancy tools you can use. So 0, it's, invalid in that it will trigger the loop to run. Because what I'm saying, a valid number is 1 to 10. And if it's not 1 to 10, it's just going to keep you in this loop and say, hey, no, I asked for a number 1 to 10, dummy. Please give me a number 1 to 10. And if you give me 20, 20 is greater than 10, the while loop is true, it'll run again. Say, hey, dummy, 20 is not 1 to 10, give me a number 1 to 10. So any value that will trigger this loop to run. Right, and we can do this again. We could have like a string for choice. And we'll start off as like a nothing string. Yeah, sure, you could use 100. Yeah, any number that means this will run. Yep, because maybe 0 is a valid choice. Maybe you say, hey, give me a number 0 to 10. Sure, right? Anything that will make it run once, to at least once, right? Just so you can use a while instead of a do loop. So I'm going to use a string for choice, and I'm going to say while choice.equals ignore case, rock. And I'll say not rock. Now here, I'm going to do a validation loop, but it's not this numeric, less than or greater than. It's, hey, did you enter rock, paper, or scissors? So if it is not rock, and it's not paper, and it's not scissors. Skizzers, why? Oh my goodness. I'm going crazy here. So this while loop here says, hey, if you entered something that is not rock, and it's not paper, and it's not scissors, the whole thing is true. If you entered any one of those and it is true, right? If it does equal rock, then not true will be false, and any false when you're anding, the whole thing is false. So you write, if 2 statements is false to the question you're asking the user. So like if you're saying, hey, enter a number 1 to 10, the while loop is saying, hey, what is not 1 to 10? Because we want it to run if it's not the numbers they gave us for a validation loop. like saying not in the sentence. A little bit, yeah. This is saying not equals rock. You could do double knots, but it's stupid, right? Not is, why? Definitely. Yeah, double negatives are tricky. Double negatives are hard. I mean, English is hard. But like when you ask your kids, like, hey, did you do this thing? And they said, no, I didn't do nothing. So if you did not do nothing, you did something. It's okay, sure. So here we're going to say, hey, give me rock, paper, scissors. If it does equal rock, or it equals paper, or it equals scissors, then one of these will become false. And because we're anding together, any false makes the whole thing false. The loop is done. And then we can say, hey, if choice is equal, ignore case. If they were paper, then we'll say you cover rock, you win. Else if the choice was scissors, you get smashed by rock, lose, else you tie. Or you're both rock. Rock and tie. Right? So I'm assuming the computer here in this case, I guess, is just going to be rock. So if you chose paper, you cover the rock and win. If you chose scissors, you get smashed by the rock and lose. If you didn't win and you didn't lose, you must have tied. Right? And this just keeps them in the loop here. Uh-oh. Oh, I'm sorry. This is the do loop. Okay, I was worried. Once for the while loop, once for the do loop. All right, so if we enter something that's not rock, paper, scissors, it tells me again. Rocka. Rocks. Rock. We both rock. You're both rock. Oh my goodness. You are... Life's going to kill me. You are both rock and tie. Not allowed to use the wrong your. That's the one of her pet peeves. Give it a little format here. Okay. And what we can do here, we can wrap all of this up in another loop, right? Right, we can say, like string play again equals a y, and while play again equals ignore case y, keep on going this whole thing here. And then we'll ask them, hey, do you want to play again? Do you want to play again? And then usually if you're giving them prompts, like you should tell them, hey, what should they enter? Like a Y or an N. Here, yes or a no sort of thing. And then play again. And equal keyboard.next line. Right? And then that will change it. And if they didn't enter a Y, the loop is false and they're done. Okay? Let's give it a try. One guess, 42, we guess the number one is valid. Okay, rock, paper, scissors. Let's do paper. Play again, yes. Scissors. Hey, Professor Burp, thank you so much for donating those bits to the Student Scholarship Fund over at the University of Michigan Dearborn, where I'm both a student and a lecturer. It's kind of fun. That's so awesome. All right, play again, yes. So we did scissors, we got smashed by rock and lose. Paper, we got covered by rock. We're both rock and tie. Do you want to play again? No. Okay, so now we have our classic RPS. Okay. Now, if we wanted to get fancier, could we do rock, paper, scissors, lizard, Spock? Yes, we sure could. Right? There's just more valid choices and more things to compare. Right? It's not too tricky to do that. We just have to add in a couple more statements here. Okay, and a couple more if-elses. Right, because you have 2 ways to win, 2 ways to lose, and 1 draw with rock, paper, scissors, lizard, Spock. Okay. Again, we're not going to do that right now because it's just we'll expand on more of these valid choices and a bigger if-else here, but no big deal. Okay. So that's cool things we can do with while loops or do while loops. Okay. So we're about at 7 o'clock. We got one more loop to cover. But this is a kind of a trickier one. So why don't we save that till after break? Hey, thanks so much, Professor Burp. Yeah, we'll see you tomorrow for sure. All right, so why don't we take 10? We'll go get some beverages. take a quick break. Again, apologies for the Spotify ads in advance. And we'll be back in a couple minutes.
reaching out, but all I feel is hollow. I wanna make you work, but all I do is make you worse. The truth is a damn hard pill to swallow. Don't you wanna come on over? Don't you wanna work it out? Don't you wanna love me better, love me better, love me now? Don't you wanna fix our problems? Baby, I can show you how. Don't you wanna love me better, love me better, love me now? Don't you wanna come on over? Don't you wanna work it out? Don't you wanna love me better, love me better, love me now? Don't you wanna fix our problems? Baby, I can show you how. Don't you wanna love me better, love me better, love me now? Don't you wanna love me better, love me better, love me now? Don't you wanna come on over? Don't you wanna work it out? Don't you wanna love me better, love me better, love me now? Don't you wanna fix our problems? Baby, I can show you how. Don't you wanna love me better, love me better, love me
Hey folks, welcome on back. Alrighty. We got a chance to get your beverage. We have more loops to talk about here. Alright, so we've done while loops, again, our pre-test loops. They test before, so they may or may not run. Do while loops are post-test loops. They will run at least once and then see if they need to run again. Now we have a third kind of loop. These are called for loops, and for loops are my favorite loops. Hey King, how you doing? I got my little can of Perrier here. Not an ad, not sponsored. Although Perrier folks, if you're out there and are interested in sponsoring a little small stream, you know, hit me up. I'll give free Perrier out to the class, right? All right. So another kind of loop, it's another pre-test loop, is a for loop. So you say for. Now, for loops are a little fun. Yeah, Java is definitely a great place to start learning and work with it, for sure. It's a very accessible first language. Java, Python, C#, definitely three of my favorite languages. Great beginner languages for sure. Yeah. All right, so the for loop now has 3 sections, which is kind of weird in a for loop. So in a for loop, you declare a variable inside this little loop header. So we're going to say int side. Hey, Jack. What do you want? Hey, you want to say hi? You want to say hi? Jack is not a cat. He's my little guy. Jack, say hi.
A shot.
A shot?
Yeah.
No, yeah, I have my shot up there, don't I? I love you. Go play, okay? I gotta finish teaching. I'll play after I'm all done.
Gotta work on it a little bit.
Oh, buddy.
He saw you talking to him.
All right. So you declare a variable here. We'll say, hey, sides is 0. Right? Or no, let's call this rows. How about that? Rows is 0. So the first portion you can declare. So just like our while loop, we declared a variable and then we had a test here. The for loop says, oh, wait, I don't need to do that in a separate line. I can do it inside the loop. So rows is 0. Then the second portion, you have the test. What is the condition that must be true for the loop to run? We'll say rows is less than 10, semicolon. Then we have, what is our update command? So right in here, like we were saying, hey, x is greater than or equal to 0. We were updating x here. In this case, we were updating x. Where did it go? Oh, we had it again. Right here, we were updating the number of guesses inside the loop here. Sure. So we'll say rows plus plus. I mean, it could be any sort of arithmetic. It could be plus equals 10, right? It could be whatever line here you want. Typically, it's plus plus. It doesn't have to be, though, right? It could be any kind of update. So you have initialize, semicolon, condition, semicolon, update. Right, to initialize a value, you have the condition for while this is true, this happens, and then you have the update. So it kind of consolidates everything into one spot here. So I'm a big fan of for loops. I like for loops a lot. Okay, and then for every row, then we want to do something. Let's print out. How about a bunch of stars, right? Let's make some ASCII art. Let's see, is it 3, 6, 8, 9, 10? We're gonna make a 10 by 10 shape here. Okay, we'll give this a little run, and we should get a nice little star when we're done. Yeah, Jack is a big Dada's boy. He is my biggest fan. Rock. Again, no. There we go. And now we get our little ASCII art, our 10 by 10 star here. Right? There should be 10 rows. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All with 10 stars. I know it's not exactly square shaped, but again, you know, this is about as close as we can get here. Okay? Let me shrink that back down a little bit. I mean, in this case, it's just, it's a predetermined, this loop will run 10 times. So it's not good for validation, right? Because we can't say, do this so many times here. But if you know how many times, like this little loop here, if you know how many times it's going to run, it's the way to go. And that's what we'll talk about again at the end. It's like, well, what should we use a do loop for? What should we use a while loop for? What should we use a for loop for? Use a for loop for. 4 for loops? You know, if you have 4 of them. Sure. All right. So we can do some cool things with these loops. It's considered very bad form in a for loop for this condition value to be updated anywhere but here. It doesn't mean you can't do it, though. So just like any program, you can shoot yourself in the foot and do it the wrong way here. So if you're updating rows inside of the loop, it will also update here in the condition. Yuck, right? And then it's going to be hard to follow, and you're not going to know why I didn't do the right number of times. So essentially, the only time you have that value being updated, you declare it here, and you update it here. Now, you could use it inside the loop if you wanted. So check this out. So what we're going to do is we're going to do another loop. We're going to say for star is 0, star is less than rows, star plus plus. Here, we're going to print, and I want to print, not print line, a star, When that loop is done, then I want to print a new line. You know what I'm going to get here? Right, with a nested loop. So for every row, I want to print that many stars. So row 1, I'll print 1 star. Row 2, I'll print 2 stars. Row 3, I'll print 3 stars. 4 stars, 5 stars, on and on and on and on, right? 1, 1, 1, 1, 1, rock, no. Now we get a nice little right angle triangle, right? 1 row, 2 rows, 3 rows, 4 rows, 5 rows, 6 rows, 7 rows, 8 rows, 9 rows. Notice I actually have 0 stars here because 0 is not less than 0. So I only get 9. So maybe I want less than or equal to the number of rows. That's probably better because then I would get my 10, right? Because I only had 9 rows here with 9 stars. Okay, I can do a cool little triangle. Oops, I should enter rock. There we go. There we go. Now we get 10, right? 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Cool. So a loop inside of a loop here. So we can use this value, but again, we're not updating it. So as long as you're not updating it, you're all good. You just don't want to be updating that value inside of the loop and in this update section. Okay, now the other dumb thing you can do, just because Java lets you, is this. Technically, the initialize is optional, the condition is optional, and the update is optional. Right? But if you have no condition, right, what's going to happen? It assumes it's true. YOLO. Right? We have an infinite loop, so don't do that. Finite loop. That sounds right. So don't do that. I'm just going to comment that out because that's no fun. Source, toggle, comment. There we go. Right? So technically they're all optional. I've never seen people do that because why? That's kind of weird. Okay? Now, Mr. Gaddis here is a terrible person in that he like everyone else out there. Okay, so maybe he's not terrible. Maybe I just think everyone else in the world is terrible. They love saying for int I equals 0, I is less than, I don't know, 10, I plus plus. Do something. I have no idea why they like to use I, because I means nothing. It's not a good variable name, and you only have to type it 3 times. So who cares how long of a variable name it is? Like, if this is the number of rows, do it. If this is the number of stars, call it that. So please, I'll make fun of you. You won't lose points, but I'll make fun of you if you start using I. And then they have nested loops. They say for int j is 0, right? J is less than I, j plus plus. And then I have the hardest time, because I'm terrible, I guess, of telling the difference between a j and an I in code. And like, did you type the j? Did you type an I? I mean, like, just glancing at it is awful. And for some people, for some reason, people love nested loops with i's and j's. A Fortran thing, okay. I mean, I thought you could have good variable names in Fortran, but I've never used Fortran in my life. So I will make lots of fun of you and tell you your variable names are terrible if you use i's and j's. You won't lose points for it, because you get points for accomplishing a task, but I'm just going to tell you this is meaningless here. Okay? So let's do this. Instead of that, right? Sure, that'll just run a bunch of times. It's not going to do anything. I don't know what. How about I colon plus I plus dash plus j colon plus j. There we go. Let's see. So I should be, so with a nested loop. Okay, I, j, and k were automatic ints. Okay. I guess they were trying to have shortcuts, I guess. So if I starts at 0 and j goes until we're less than I, right? Every time we have I, we're going to get j number of times, right? So when I is 0, this runs no times. When I is 1, this runs 1 time. When I is 2, this one runs 2 times. When I is 3, this one runs 3 times. So for every run of the outer loop, the inner loop runs start to finish. Sticks a longer variable name? No, so in compiled languages, Java will actually strip out your variable names and reassign them, right, to essentially just, here's a list. Or at least with any smart compiler. Pretty sure Java does it. I know the .NET compiler does. So like your variable names get disappeared, essentially, because it wants to be saving as much space as possible when it compiles, which is really cool. The people who study compilers and people who write compilers are fantastic people, and I love them, but I have very little clue as to how compilers actually work. I never took that class. Honestly, as interesting as it is not anything that ever interested me and said, no, I want to work on that. I'd rather solve other problems. But again, like compilers can do really cool things that simplify your code and do those updates. Here we go. Right, so for every loop of I, we get j. So with I is 1, j 0, and then it stops, because when it equals, it doesn't run. So at 2, we get 0 and 1. At 3, we get 0, 1, and 2. At 4, we get 0, 1, 2, 3. At 5, we get 0, 1, 2, 3, 4, on and on and on and on. So with a nested loop, a loop inside of a loop here, for every run of the outer loop, the inner loop runs start to finish. Then when that one's done, we come back here, we come back to the update, we come back to the test, or the condition. Is it true? If it's true, it runs again. So kind of a lot of things happening going on. Hey, Amazing Bhop, the schedule's there on my Twitch page. Okay, so that's a nested loop. So now for fun here, let's do for int hour is 0, hour is less than 24, because we want to get up to 23, sure, hour plus plus, and then we'll say for int minute is 0, minute is less than 60, because we want to get up to 59, minute plus plus, and then we'll say for int second is 0, second is less than 60, second plus plus. We're going to print here, second with the D there. Now we want to actually format this prettily here, so we want to do a printf. Remember printf for formatting? I want a %d digit, but I want it to be 2 spaces wide. So 0, 0, right? Colon, %2d, another 2 space digit, colon, %2d, and then I'm going to give it hour, minute, and second. Then I also want to add in my own new lines, because printf doesn't give you new lines. So please don't memorize this. This is not worth having in your head. Just go Google how to do string formatting or print formatting. Here, right? Sure, or you know what, here, let's do print line, and we'll do string.format. Do we look at string format? Does the exact same thing, essentially, but it's better than printf. But I think I recommend it against using printf, because string format does all the same stuff, and then you can use it other places that are not printing. So like when we get into GUI applications, we can string format for all of our GUI stuff if we need text. It's pretty cool. So we're going to see all the possible times in the military time clock, a 24-hour clock. Here we go. Uh-oh. You didn't pad it right. All right, I Googled it wrong. King, all right. 2 classes for summer started today. What a summer. So, okay, so I get 2 spaces, but I don't have the 0 there. Is it 02? I think it's 02. So I think 02 says if it's padding, use a 0. Let's try that. I think that's what it is. If not, we can Google. We'll try that. Rock. No, there we go. Cool. So now we have the padding with this. Now we're just displaying all of the times. Now, a funny thing about Java and running programs here. Notice this looks like it's taking a while. The slow part of this program is actually the system.out.print lines. Print line is not the fastest command in the world, and we just ran it, what is 24 times 60 times 60. We just ran it 86,400 times, right, in 22 seconds. So, I mean, that's relatively quick, but if we're not printing here, if I just comment that out and don't print here, oops, oh shoot, I entered the wrong value. If you enter a word for a number, it just crashes. We'll learn about that later, don't worry. Rock, no, here we go. It's done in, we don't even see it, like 6 seconds. It does those 86,000 operations like that. right? It's only because we were printing that it's really slow. Okay? And that's all right. Don't worry too much about it, but just know that printing is a slow operation, right? Is slow. Okay, the actual arithmetic happens super fast. 86,000 operations, no problem to Java, right? No big deal at all. We probably don't need to run it again, do we? That's fine. Okay. So let's take a look at some other uses of some loops. Yeah, I might have just optimized them out because it did nothing. Maybe it did. Yeah, I realized, oh, nope, we're doing nothing. Just skip it. Sure. And we're about to get to those keywords, Yule and Caw. Yule and Caw. But ideally you would just like stop your loop here or have an if inside of here. Like if the hour is this, don't do it. Got lots of options. Right? Like what hours did you want to not show? Yeah, not search for 11, so we'll just say in less than 12. We could stop it that way. Right? Or we could put an if in here, right? So if hour is less than 12, do this thing. Sure, we could do all that, right? Lots of options there. I'll leave that out for now, though. Okay. So another cool thing you do with loops here is you can start generating some totals. Right, so we'll say int total starts at 0, and now what we want to do is we want to run a loop a bunch of times, right, where we're going to be adding to total. So, sure, well, let's just ask the user. We'll say for int value 0, value is less than 10, value plus plus, and then we'll say, I don't know, please enter the, I don't know, how about we'll add in here value, right? So like the 0 value, or sure, how about we start at 1 and we go less than or equal to 10. And to the 1 value, the 2 value, the 3 value, the 4 value. It's not pretty English, but that's fine. And then we'll take total plus equals integer.parseInt given keyboard.nextLine. When we're done, we can spit out the total of those is plus total. We'll spit out total. Right, so this will do it exactly 10 times. Right, because that's what I know the loop is doing. Rock, no. Oh, I have all these printing out. Oops. Hold on a second. Maybe I can drink some more. Man, my office is getting hot up here. I got myself another fan because my wife took the other one. She really liked it. Here we go. All right, so enter the first value. Sure. 10, 10, 10, 10, 10, 10, 10, 10, 10, 10. Total is 100. Look at that. We can total up a value here. Pretty handy. Okay. Now, what if, though, we don't know how many numbers we have to enter? Right? So we'll have like a total sales. Starts off at 0, and we'll say, how about an int receipt? Right? If we want to like total up all the receipts. What I'm going to do, I'm going to give it a value here that will make the loop run. Okay? Right? I don't know. Or maybe a do loop. Sure, why not? We'll say do enter the receipt total or -1 to stop. So here I'm going to say -1 is the clue, or I don't know, how about 0 to stop? We'll say 0 to stop. That they need to stop. So I'll have an int for receipt, integer.parseInt, keyboard next line. And we'll do this while receipt does not equal 0. So while receipt does not equal 0. Uh-oh. It doesn't know what a receipt is. Remember, if you declare a variable inside a set of curly braces, its scope is that curly braces. It only exists inside those curly braces. So I'll say int receipt up here. And then over here, I won't have to tell it it's an int again. Okay? And then I'll take my total sales, total sales, plus equals the receipt. So for as many receipts as you have in that register, in that stack, you just keep on entering, keep on entering, keep on entering, keep on. It could be 5, it could be 500, it could be 1,000. I mean, as much as you have to do until you enter a 0. It's just going to keep on going in this loop, because as long as it's not 0, we're going to run, and we'll just keep adding it to our total sales. Total sales for those receipts. Leave a $sign to make it look kind of pretty here, right? Plus total sales. Okay, so we can just keep on entering. So this value here has a special term. It's called a sentinel value. The sentinel value means, hey, this is not a normal value you'd expect to see. You probably don't have a receipt for $0 in your drawer. You might have had a -1. Like if you had to refund $1 for something, maybe you had a -1. That's fine. So Mr. Gaddis's example is like, hey, how many points did your team score for all these games? Like if we want to track total points for a tournament or something silly, right? And -1 is probably not a valid number of points to score in a game. Sure, but 0 is. So the sentinel value here needs to represent an invalid value, right? It's a specific value that you're using that you would not expect to see normally. That means, hey, stop, right? So 0 is our sentinel value. Value that means stop. Not a normal value. Okay? So it could be tricky to come up with a sentinel value depending on what your application is. But in this case, if I don't know how many times it's going to run, I can't use a for loop, because the for loop says, hey, run, start here, go here, add this, or minus this. You can also do for loops backwards, right? You can do less than, minus, minus. You can decrement, and you can go until you're greater than a value. They both work, okay? You okay so far? Okay, no complaints. Good. All right, now I'm going to show you 2 keywords here, and again, I will typically avoid these if I can help it, but they mean special things. So if you have a loop, we're going to say, I don't know, how about for int number 0? Why not? Number is less than 10, number plus plus. Nope, I already used number. That's right. I think I already used value. I got too many of these loops going on here already. Let's see. Some number, why not? Sure, maybe I could have used I, but again, that's sure. Now, what we want to do is we want to print these numbers if they're even, just for fun here. So we could say if some number modulus 2 equals 0, we'll print the number. Okay? So it should only print the even numbers. Oh, oop, I crashed it. I knew I was going to do that. This example is getting too long, I'm sorry. Rock, no. Oh, I still have all the time here. Okay, I gotta go comment out. Almost there. Enter the first value, 1, 1, 1, 1, 1, 1. Right, enter receipt totals, 1, 1, 1, 1, 1, 1, 1. Sure, that's enough. We'll enter 0 to stop. We get $4. Sure, we get... Huh. What just happened there? 66, 66, 66, 66. Oh, number. I should have printed out some number. There we go. And we want less than or equal to 10 probably here, right? There we go. Yeah, if you print out number, that was still stuck at 66. I was a little confused. Rock, no. 1, 1, 1, 1. 1, 1, 1, 1, 0. All right, so 0, 2, 4, 6, 8, 10. Awesome. Okay, with this. Sure, we'll print the number. Now, other ways we could do this if we wanted to be clever here. Okay? We could say, hey, if the number equals 1, we can use this cool keyword called continue. Now continue means stop the loop, go update / check condition. So in a for loop, the condition will still run, and then we'll go here. You can use continue in a while loop, and there's no update, but it'll still check the condition. So this is why I don't like it, because in the middle of a loop, you just stop doing the loop and go back up to the top. I find it confusing. I mean, there's some really good places to use it, some really cool examples, all well and good, but I find it confusing. So if it is 1, we're just going to continue. If we didn't continue, we're going to print out the number. It's 1, 0. There we go. So now we get 2, 4, 6, 8, 10. Again. Continue. Right, we can also say, hey, if some number equals 7, how about 10? There we go. We'll do 10. And we'll do this after. I'm going to say break. Break says totally stop the loop, abandon ship, you're done with the loop. So in here I could say, hey, how about less than 100? But as soon as we get to 10, we're going to break the loop and stop, game over. But again, this is also why I don't like breaks, because it's kind of confusing and awkward to have, here's a condition, need original name, use a go-to function. So breaks are just confusing because the loop just stops outside of the condition being true. Rock, sure, no. Oh my goodness, I'm typing too fast here. I'm sorry, folks. Should pay more attention. Rock. No. 1, 1, 1, 1, 1, 1, 1. 0. There we go. So it stops at 10 because we have this break here. So again, I'm not a fan of them. If you like them, great, but I just find them confusing. So, and like, if you have to, I don't know, you can always add something in your condition here to make it stop instead of a break, usually. So, sure, break and continue. So we have one post-test loop is the do while loop. It will run at least once. We have the while loop, which will run as long as this is true, right? For any number of times. It's great for like accumulating this, like finding a total here. We'll call that an accumulator, right? Because we're accumulating a value here. We just keep on adding to that total, right? Great for accumulators. If we don't know how many times it's going to run, we just keep going until we get some sort of sentinel value. Fantastic. For loops are great if you know how many times they're going to run. You get it all in the header, it will run that many times, life is good. Right? Some sort of counting value is typical. Okay? So that is loops. That's the first half of chapter 4. Don't know why it's so many different sections. We also now have files and then random to talk about. So let's actually do random first, because I think that's more fun here. So when we were doing our guessing game here, instead of saying, hey, does it equal 42, let's do this. Let's put this here as int random number is, now to use random number, we need a random object. So we say random equals a new random here. And yes, we want to import from java.util.random. Now the funny thing about random is that it's not actually random. And hopefully you've gotten the clue here from, you know, the computer does exactly what we tell it to do, and only what we tell it to do. So to generate a random number, it's really a pseudo-random number. It's sort of random. The way that it does it is every time you make a random object, it's taking your computer's clock time and using that as a seed value for generating a random value. So as far as we care, it's essentially random. But don't use it for things that actually need important random numbers, like cryptographically secure things. There's other ways of doing that. So just the warning here, right? This is not for cryptographic stuff. Right? Anything that needs actual random stuff for security, don't use it, because it's only sort of random. We'll say random dot, and now random dot, you get a bunch of, yeah, I think it's probably secure random. I don't know. I've never actually done a cryptographic anything in Java. So I've only ever used random just for the play stuff we do. So you say next int. And next int, I always use the one that has a bound. So with a bound of like 100 here, we'll get the numbers 0 to 99. So I'm going to say +1 will give me 0 to 99 randomly. +1 gives 1 to 100. Okay? And then we can tell them, hey, guess a number 1 to 100. And then I can check, hey, is it equal to the random number? Is it less than the random number? Or is it too high? Okay? So let's see. So 50, 25, 12.5, 13-ish, 6, 3, 2. So for any of these, I should be able to get it, I think, in 7 guesses for any number here. Because what we're going to do is we're going to split the difference. We're going to go 50. That's too low, so we're going to split the difference. We're going to go 75. That's too high, so it's between 50 and 75. Right? So I had a range of 100. I cut it down to 50. I'll cut it down to 25. I cut it down to 12.5 or 13 essentially here. Right? So like 68 or so. Still too high, so between 50 and 68. So halfway is 9, so 59. Too low, so somewhere between 68 and 59. Let's split that difference. I think that's what, 64 is too high. So between 59 and 64, let's go 62. It's too high, so it's either 60 or 61, right? So how many guesses was that? There's 1, 2, 3, 4, 5, 6. Uh-oh. Shoot, I might be off by 1 here. So let's do 60. All right, we got it right. Okay, so maybe I need 8 guesses to get it exact. Enter a number. Sure. Rock, no. Yeah, okay, we can stop. We only updated it here. So this gives you random numbers. So random is awesome just for some silly random stuff we're going to do. Okay, and then we can do this little guessing game here using random numbers. So I don't actually know what it is. I don't have to hard code in the number 42. Okay? Does that make sense? So it's all for random. You can do some fun stuff with it, but it's a quick little generates a random value. You can get floats, you can get doubles. If you don't give it a range here, it gives you any possible integer, which is like -2 billion to +2 billion or so. For right now, we're just using it to guess a random number, just for fun. We could also use random here for rock, paper, scissors. Right? We could do that. Let's do that one. Let's throw that in here. So we'll have a string for computer choice. Oh, actually, we need to figure something out first. So we're going to say, let's say int computer choice, computer throw is random.nextInt, and we want to go up to 3. So I'm going to have 0, 1, or 2. So if a string for computer choice, sure, and then if computer throw. Oh my god, computer throw equals 0, then we'll say the computer choice is equal to rock. Else if computer throw equals 1, the computer choice is equal to paper. Else computer choice is equal to scissors. So get a random number, 0, 1, or 2, because remember, it does not include this upper bound. And then if it was a 0, it's rock. If it's a 1, it's paper. If it's a 2, it's scissors. Great. Get the user's choice, and now let's check to see what happens. So I'm going to do a win case, and I'm going to do a tie case, and my else case is the loss case here. You lose, right? You tie, you lose, you win. So if the user's choice is paper and the computer choice, yeah, let's do this. Let's, you know what? We probably don't even need that string here. I'm sorry. We don't even need the string, because we can just use the number, right? So again, I'm going to feel a little bit bad, but like 0 is paper, is rock, 1 is paper to its scissors. So I feel a little bad having a comment here, but again, this is probably easier than... Okay, no, I'm feeling bad. I'm going to undo it. Forget it. We'll use the string. That's more clear anyway, right? We'll put it all back. Okay. I put it back. I'm sorry. So if the users is paper and the computers equals equal. And now I don't need to ignore case because I know it's lowercase because I'm the one that put it in. I did ignore case on the user's choice because I don't know if they typed uppercase, lowercase, whatever. So if your paper and the computer is rock, that's a win. Right? That's one way to win. Or, what's another way to win? If you are rock and the computer is scissors, you win. If you are scissors and the computer is paper, you win. So there's 3 different win conditions here, right, for rock, paper, scissors. Oops, is it computer choice? Sorry, computer choice. Okay, so you can win if your choice equals, ignoring case, the computer choice. You tied, right? If your paper and their paper, you tied. And if you didn't win and you didn't tie, you must lose. I don't want to have to repeat this for all the losing conditions. Right, so now we can use random here to get a rock, paper, scissors for the computer, and we can play as many times as we want. Okay, so we'll play rock. We tied. Play again. Yes. Rock. We win. Yes. Play again. Rock. We tied. Play again. Yep. Rock. We tied. Yep. Play again. Rock. We tied. Play again. Yep. Rock. We win. Yep. Play again. Rock. We win. Yep. Play again. Rock. We tied. Yep. Rock. You lose. Okay. Finally, we lost. I was waiting to see if we would lose. Right. It took us a while to lose. Rock was pretty solid there, right? That was a pretty good winner for rock. Not too bad. Okay, play again, no. Do the rest of the stuff. And we can just stop it, right? Because we were just modifying stuff in the middle here. Okay, so this is loops and random so far. I'll make a new project for files. Okay, so we start a new project here. Call it chapter 4 files. Okay, this way we don't have to rerun all that other stuff there. Okay. All right, awesome. You folks okay so far? Need to go play with it, read it, spend some time with it. Please do read the textbook. It is very valuable for you folks to read the textbook. Right, I'm trying to pull out the highlights. Mr. Gaddis gives you other examples. I try and give you different examples, right, and stuff that's not copyright by Mr. Gaddis. I mean, sure, that sort of thing. Okay. I know we're covering a lot tonight. It's a long night. You know, it's a lot of stuff we got to get through here in the class. So material just keeps coming at you. So you definitely want to be keeping up. Once you get behind, it's hard to get caught back up because we just have a lot of material. Okay. Cool. I got it all out there for your review later in the course GitHub. I'll post it all. What are randoms using for? Like, what are we doing with random Yule? Yule and call? Yule and call? So notice, again, we didn't get to forget any of this if, else stuff, right? We're still doing all the same stuff from chapter 3, but now we can do cool stuff inside of loops with it, so we don't have to have the same code twice. Because a good rule of thumb is if you have the same code twice, you should feel bad about yourself. It'll still work, and it'll be okay, but you just have worked probably more than you needed to. That's all. right, we have files to talk about now. So I got my new chapter here for files. So there's two things we do with files, right? You read from files or you write to files, and we're going to do them separately. Technically, there's a third way, but we don't talk about that until the next class to be interacting with files. And it gets messy anyway. So you read from files, you write to files. And the great thing about files is, remember back to chapter 1, they get written out to disk or secondary storage so that when our computer turns off or we lose power or anything, the file will still be there, right? So we can have persistent data rather than just everything being in memory, right? If I have an integer in memory or I have a string in memory, it only exists as long as the RAM is on, my program's running. As soon as the program's done, operating system takes the memory back from Java. So though you don't need it anymore, it's gone. So being able to persist stuff to disk is huge, because now we can have data that exists and lives beyond us, right? Or beyond the program running. And then so we could have one program write some data, have one program read some data. We've got lots of fun options here for what we're going to do with it. Okay, so we'll look at writing file first. Okay, there's the two types of files, binary files and text files. We're doing everything with text files. The binary files get a little confusing. So, and again, that's a topic for next semester as well. Okay, we're going to do all text-based files. Okay, so if you want to write to a file, you have to do a couple things. It's not too bad. We're going to use the thing called print writer. We're going to say print writer. This is my output file. Sure, why not? Equal to new print writer. Given, and then here in quotes, we give it the name of the file. Testfile.txt. Okay, and Java will say, hey, do you want to add an import? Yes, at java.io, right, for input output, print writer. And now it's still mad at us. It's saying, hey, an unreported exception, file not found exception, must be caught or declared to be thrown. We haven't talked about exceptions yet. We'll get to that near the end of the semester, and I feel bad about that. But it doesn't make a whole lot of sense to do it earlier. I don't know. I'm still torn. But for now, what we do, we click the little light bulb, and we say, add a throws clause. Okay? So what this is doing is saying, hey, a bad thing might happen that'll make my computer crash, my program crash. Just pass the buck. Right? Okay? It's no big deal. If an exception happens, throw it in our main class here. That's okay. That's what we're going to do for now. Right? We're going to say, if a bad thing happens, forget it. Uh-oh, I'm losing some bitrate here. What's going on? What do we got here? All right, still sort of there, but it's kind of laggy. How's it look on your folks' side? So I'm still dropping frames. Okay, maybe I'm back. Nope, down again. Sorry, folks. We'll give it a second. Ooh, unstable. That's yucky. All right, it's thinking about it here. Come on, Comcast. Work with me. Work with me. All right, I think we're back. Okay, we had a little unstable period. We might be back here. We'll give it just another second here. Hopefully it's not too bad for you folks. I'm sorry. This is when Zoom gets funny. It goes, wah, 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 wah. Right? Ay, ay, ay. Okay. Cool. I think it's pretty stable now. Let's give it another second, see what the refresh thinks. Okay, cool. So I think we're stabilizing. Sorry about that. Hey, thanks so much for following, folks. So cool to have you along. All right, so what this is going to do And with PrintWriter, it's going to create a file named testfile.txt. And then what we got to do is output file dot, and now we get some cool commands here. You can append, you can print. So I'm fond of printline because this is very similar to what we were doing before. So I'll put in, oh, let's do hello world. Why not? Hello world. So anytime you're working with files, you have to do three things. You will open the file, you'll read or write the file, and then you'll close the file. So you have to do all three things every time. So then to close it, output file, we call .close. Okay, so let me run this here. It's not going to look like anything happens. It's just boom, done. But if I go over to the Files tab here, and I open up my Chapter 4 files, I'll see there's a testfile.txt. I can open it up, and it says, hello world. Notice there is a second line, because we used new line, print line, which gives you the new line character. So we're at the second line here. Let's go add some more here, right? Let's hello world. I can make files now. What should we put in here? Okay, we'll run that. Now you do want to be a little bit careful because what happens with PrintWriter is it actually overwrites and will blow away anything that was in the file previously. So PrintWriter is a little bit dangerous. Overwrites the file, essentially. So we can write to a file. You can use printline just like we did with system.out.println. You can print numbers, you can print text, you can print all sorts of things. Can you show at the output the information at the file? I'm not sure what you mean by that, Yul and Kaw. Like in this output tab here, show what? Hey, thanks so much for following along. Glad to have you folks here. To show the same hello world at the output, it has to be two different commands. So this print line is printing it to the file. You could also use a print line to print it to the console, the standard system.out.println. Right, so like system.out by default is our console, right? That's the console here. Output file is our PrintWriter over here. But we could read the file, right, if we wanted to. Hey, Ignigmagson, you probably want to go back a couple videos there. Exclam YouTube. We are in week 4 of the class already. So if you back it back up to about week 1 or so in the YouTube archives, we'll talk all about that. Essentially, it's where Java starts the program. When you run a Java program, it looks for a main method to run, and it's got to look like this. That's the only way Java knows how to start. Okay, yeah, exclam YouTube there in the chat. We'll give you the link. So we could read the file though. So to read a file, we do a couple other steps. Okay, that's printing, printing, exceptions. Yep, we have the throws clause. Reading, there we go. So for reading, we do two things. You make a file object. So you say file, we'll call it the input file, equals a new file, and you give it the name of the file. So this is testfile.txt. Then what we're going to do, we're going to add our import here. Yep, add the import. Awesome. We're going to use scanner again. We're going to call this the file reader, equals a new scanner. Instead of giving it system.in, we give it the input file. Scanner can read files too. Scanner is a pretty cool class. And Java says, oh, I want to import scanner. Yep, import scanner. Very cool. Okay, so it has the exact, not exactly the exact same lines, but we're really close. So, actually, yeah, all the same methods will work. So what we're going to do is we're going to say while FileReader.hasNext. So FileReader will tell you if there's another thing to read. It's really cool, right? That's the scanner. It'll tell you if there's something for it to read here. We can print out FileReader.nextLine, right? And we get all these next. So you can get next ints, next lines. Again, it's really tricky when you're reading a file to know what the contents are. So next line will always work because you can get anything as a string, right? But if it's not an integer, nextInt is just going to crash on you. Okay? And then when we're done, we close the file. So file reader dot close. Okay, so you open, you read write, and then you close. Right? So you open files, read write them, close them. I won't say files. Right? Always those three things. So now we'll be able to read the contents of that file we just created. So the contents were, hello world, I can make files now, and what should we put in here? Pretty cool. Or you could go look at it over here. Okay? Does that part make sense so far? So some other cool things you can do is, notice we didn't tell it where to make the file. It will make the file in the directory in which it's running. And that is a little bit silly here, but what happens is it's actually running. Where is it running from? Right here. So this ANT-F is running from this folder. So this is the folder which is being run. So the file gets created inside that folder. Okay, that's why it's right here. And when I go to read a file, I don't tell it where to look. I just say, hey, read a file here. It's going to look in the directory in which it's running. So what you could do if you wanted to, you could say, hey, put it in C:/test/test file. And then go read it from C:/test/test file. And then I'll go to my C drive and see if I have a test folder. Oh, I don't have a test folder. Okay, so it's going to crash. It's going to be really upset with us. Look, file not found exception. C test file. System cannot find the path specified. It crashed. That's this throws file not found exception. Your program crashed real hard. Well, that's okay. Sure, let's go make one. So let me go back to my C drive, make a new folder called test. Now when I run it, it works. And now if I go look in my C test folder, there's a file called testfile.txt. I can open it up and I'll see the contents. So you can use full paths if you want. Now the tricky part in here, and Java has gotten much better about it, forward slashes are technically not Windows paths. You'll notice if I look at the path here in File Explorer, it's C:\\. The problem with backslashes, you remember if you put a backslash in a string, it gets really confused at you. So you need to do 2 backslashes to be, hey, an escaped backslash. I really meant backslash. But what's cool is Java is smart enough now to say, hey, if you gave it a forward slash, it really needs a backslash because Windows likes its backslashes and gets confused otherwise. So I will always prefer forward slashes to these double backslashes because I'm lazy, right? It's just easier. But you can use either one you want, okay? No big deal. It's pretty cool like that. All right so far? Now, another cool thing we can do, so if we want to avoid crashing here, so okay, we'll leave those, why not? How about we'll say a string input, we need another scanner here, so hang on. Let's do scanner keyboard equals a new scanner, this time given system.in, and we'll say enter the name, a file to read, and we'll get a string for file name is the keyboard.nextLine. Okay, and then we'll make a file. I'll say file, I don't know, users file equals a new file. And instead of saying, hey, you are this path here, I'm going to say, hey, you're the file name. Now, what Java is really cool at is it knows about files. So I can say if users file dot, and I get all sorts of cool things here. The one I care about is exists. If it actually exists, then we can go do something with it. Hey, Groovepunk, thanks so much. Yeah, this is a lot of fun. So if the file exists, then I know I can go read it and do this thing with it, right? We'll do another file input. Sure, why not? We'll say input file, we'll say scanner, sure. And instead of this being a new file here, right, we just hand it user's file. So if it exists, go read it. If it doesn't exist, we'll print that file doesn't exist. Okay, so when I run it, again, we'll make that C colon with whatever, but this one doesn't have a relative path. So enter the name of a file to read. If I just say test file.txt, I get the version that's right here, right? That's in my directory because I didn't give it a path. Maybe we'll say that. Maybe we'll say reading, and then we'll add in here file dot, oh, sorry, users file dot, what is it? Something about full path, or get path. Get absolute path. Probably get absolute path. That looks right. We'll try that. Okay, so if we say test file.txt, yep, C users, Eric C, documents, GitHub, CIS 152151, chapter 4 files, test file.txt. That is the absolute path. So absolute path means I start with the drive. Drive, folder, actual file. So how about we say, try it again, test.txt. Test.txt doesn't exist. Nope, it cannot, it does not know what extensions are. So if we just say test file, it'll has no idea. Test file doesn't exist. If we run it again and we say test file.txt, all uppercase, it does not care about case sensitivity. So that might be specific to Windows. I don't think so. I don't actually recall, but I know it does work in Windows. I don't have a Mac, I'm sorry. But usually files are not case sensitive. Right? So testfile.txt is the same as testfile.txt. Right? Whether or not you're shouting at me or not, it will go read it. Okay? It thinks it exists. So typically they're not case sensitive. But you can check if the file exists or not. So you can tell it to look anywhere you want. So I could go say, okay, let's go find a silly file here. So I've got this OBS current song that has a song.txt file, or current song.txt artist. Those are all blank right now, but that's boring. They're all blank. Hang on, let me start this back up and mute it. Sorry. Okay, so now they're full. Okay, so I've got a current song and an artist. So I can go read the contents of current song. So I need to give it this whole path though, right? So it's current song.txt. I'm just going to copy that in, and when it asks me to run, right, for the name of the file, I'm going to give it that. And the contents are More Plastic by Feel Alive, or Feel Alive by More Plastic, I forget, one way or the other. So I gave it the path to read, and it went and read it. This is the contents. So you can look anywhere it has access to. Okay, so I could go read this out. That's what OBS is doing essentially when it's like putting these files in. It's just creating text files. It sits and watches my Spotify to see, hey, what music is running here, what music is playing right now, and then puts a file out there, and then OBS says, hey, I'll read the contents of the file and put it as text on your screen. It's kind of fun. Okay, so that's for checking if files exist or not, right? You read files, you write files. The one other cool thing you can do is you can open files for appending if you want. So let's do another one here. So we'll say enter name of a file to write to, and we'll get a string for, I don't know, file name, keyboard.nextLine, and we'll make a, oops, oh, file name is already, okay, that's fine. We'll just overwrite file name. So file name is that, and then we'll say, okay, sure. Well, let's ask them again here now. Do we want to, you want to overwrite or append to the file? So appending to the file, and I'm going to say O/A for overwrite or append. Just as like a little helpful hint here. Which one should you give me? And then I'll have a string for mode, maybe? I don't know. Sure, why not? Mode, it's keyboard.nextLine. And if mode.equals ignore case, if it equals O, then I'll go into overwrite mode. Else I'll go into appending mode. Okay, so the difference with those is using another object. It's kind of a little silly, but it's okay. So we'll take a look at that. So you still make a print writer, but you give it something else. So if we're in overwrite mode, we don't need to worry about it. Okay, so maybe only for append mode. That's okay. So I'm going to say here's a print writer. This is my custom file writer here. So if we're in overwrite mode, custom file writer will equal a new print writer given the file name. Okay, they gave me the file name where we want to overwrite. So print writer, like we did up here, will always overwrite the file. Okay, if we want to append to it, what we do is we create a file writer. I don't know, file writer equals a new file writer given the file name and true. So true here is what puts it in append mode. So please don't memorize this. Just go look it up in the text here. When you go write files, that's appending to a file. So you make a file writer and you pass it true. Then instead of giving print writer the file writer here, oh, and I got to import that. We'd say print writer equals a new print writer. Oh, sorry, lowercase p. Print writer equals a new print writer. Instead of giving the name of the file, we give it the file writer. Oh, yep, and this might throw an exception. So sure, add a throws clause for java.io.exception. So technically an IO exception is, or a file not found exception is an IO exception. So you could like take that out if you so cared to. Just if it bothers you, it doesn't really matter. Oh, custom file writer, sorry. Custom file writer is a new print writer. So the file writer here can append to files. So it'll open the file and just then anything you write will go at the end of it. Print writer is just going to blow away the file and put just the things you put in there. So we'll ask them what should we write to the file, and we'll get some, I don't know, input equals keyboard.next line, and then we'll take my custom file writer dot print line, the input. Oops, sorry, string input. And maybe we do this in a loop. Maybe we have a Sure, we'll do this. We'll say string input equals an empty string, sorry. And while input does not equal quit, I'm sorry, can't use that, dot equals ignore case, quit. And while it does not equal quit, we want to keep on running. Trigger to the file, or quit to quit. Here, I'm actually going to do this up here. So it's going to print just a blank line, and then, so okay, so we'll say, here's a string for input. Oops, oh my goodness, it put a semicolon there. Why did it put a semicolon there? That is awful. No semicolons. So we'll say, okay, start an empty string, and if it's not quit, run. I'm going to print the input here, which right now is just a blank line to start. That's fine, and enter. What do they want? Get the input. If it's not quit, this will run again. We'll print it, ask them again. If it is quit, the loop stops. So we're letting them write a custom file themselves. So testfile.txt, sure that we read it. Okay, so enter the name of a file to write to. How about a list of, I don't know, fruits. Okay, do you want to overwrite or append? We can overwrite, sure. So what should we write to the file? How about apple, banana, peach, quit. So now there's a list of fruits. Oh, notice I didn't even give it an extension. I forgot to give it .txt. Oops, it's empty. Uh-oh. Well, I forgot to close the file. Custom file writer.close. I forgot we got to open it, read write, and then close. Let's try that again. List of fruits. Were we actually appending to that one? Oh, yeah, custom file writer print line. Okay, so I think probably I just forgot to close it. Let's try that again. So I'm going to go delete list of fruits. What did I do here? Delete list of fruits. Try running it again here. Well, I mean, it just depends what you're designing, Groove. It's all about what you're trying to solve. Testfile.txt, name of the file to write to. Let's say fruits.txt. And let's do overwrite mode. Sure, it's empty, it doesn't matter right now. So apple and banana and peach and quit. Okay, and then we'll check out our fruits.txt. Now we have apple, banana, peach. Notice there was an empty beginning line. Sure, whatever. And then an empty line at the end here as well. So now let's open it again. We'll run it again. All right, so name of the file to read. How about fruits.txt? We get blank line, apple, banana, peach. Enter the name of the file to write to. How about fruits.txt? Let's put it in append mode this time. So let's add some more fruits. How about a plum, or a pear, or a watermelon, and then how about quit? And now we see we get plum, pear, watermelon. Pretty cool. And again, we have a couple extra lines, so I'm feeling a little bad about that. Let's go fix it. So instead of doing it this way, we could also do another check for if it's not quit. We could do that. Sure. So we'll say if input does not equal quit, then we should write out the input. How about that? So if it's not quit, so I feel bad that it's in here twice, but again, you know, sure, why not? It's probably okay. Don't feel too bad about that one, because you don't want to write that sentinel value that means stop the loop. Okay, so now if we run it again, let's do fruits.txt, fruits.txt to write to in overwrite mode, and let's write some fruits. We'll do apple and banana and watermelon and quit. Now if I open up fruits, right, it overwrote. All the previous contents are gone. Right, so you can do overwrite mode or append mode, either way you want. Okay, I know it's a lot tonight. This chapter 4 is a little bit big with while loops and files, but it's okay. You need loops to make files make sense, right? You can't really read a file till the end unless you know what a while loop is. So that sort of makes sense that he would put it after loops. I don't know why it's not its own chapter though, but that's okay. Right, we went through loops relatively quick. We had some fun. Okay. Questions, thoughts, concerns? How you folks feeling so far? I know it's a lot, and that's why we're going to go practice it here with our next project. Just pausing for a minute here for questions. Don't even know what to ask. That's okay. That's all right. It'll take some practice, right? Read through the text, go through Mr. Gaddis's examples. Right? He's got lots of good practices for writing some silly loops, doing some fun little things, little counting loops, or printing out some ASCII things. Like we did the little triangle. You can do all sorts of shapes and loops. Yeah, it definitely takes some time to sink in. Don't worry. We're adding to that toolkit. Right, of things we can make the computer do. So now we can make the computer loop and do the same thing multiple times. So I'll commit all the files here. At the end of each chapter, Silver Dart, he's got a list of things you can practice. I don't know, some people like to follow along and modify them as they go, and some people just like to read it. I was never fond of typing the same thing someone else typed, but that's just my style. A lot of people like trying to follow along with an example and then play with it and say, well, how can I change it, right? What can I do in here to make it different than what we did in an example, right? So what if I change some of these things? What if I change the number I'm checking here? What if I'm not doing odd numbers or even numbers or that sort of thing? What if I want to go crazy with my loops here or print different I's and J's? Right, you can modify any of this stuff. You can make this rock, paper, scissors, lizard, Spock if you wanted. Sure. Yeah, if you want to go through the examples Mr. Gaddis has, that's great. More examples are always good. You gotta spend time practicing. Okay. You folks need a break, or should we good to talk about Project 2 now? I'm open to either. It's totally up to you folks. All right, cool. Yeah, that's all the chapter 4 we've covered now, Silver Dart. Cool, we'll talk about the project then. Let me pull up D2L here. We'll go to our next assignment. All right, Project 2. This is due in 2 weeks. So that's the 21st, right? At 6 p.m. That math look right? Yeah, 1421. Yep, cool. Add a new score here in the gradebook. And you will submit just the text here. Oh, I gotta make that classroom link. Give me just a second. Sorry, folks. Start up that new link. Oh, I have Project 2. Cool. I have a link. There we go. Please submit the URL of the feedback pull request along with a self-assessment using the rubric. Okay. Yeah, Project 2, everything's through Chapter 4. If-else statements, control structures from Chapter 3, loops and files from Chapter 4. Okay. So we're going to create a shopping list application with 2 modes. The manage item mode allows the user to create files that represent the items for sale in the store. The, I don't know, shop mode? I guess it's not even really a shopping list. It's called a shopping application. Shop mode allows the user to try and purchase items. Yeah, I saw on Loco, like 2 people had issues with the feedback pull request not being there, but it worked for everyone else, so I'm not exactly really sure what happened with that. It was a little confusing to me. Not sure. Oh, I forgot to pause Spotify. Look at that. My mistake. Okay, so in manage item mode, here to enter the name of an item for sale. The file, you're going to create a file with that name, then ask them for the price. Write the price of the item to the file you just created. Then to create as many items for sale as they want. Okay, so this just says, hey, what's an item for sale? You'll take that, you'll create a file with that name, and then you ask them for the price. Write that price to the file. Right, so if I say, hey, what I want to sell is Perrier. Well, how much does Perrier cost? $3.29. Sure, write $3.29 to the file. Okay, and then we'll loop. give me another file, give me another file, give me another file. And kind of with one of these sentinel loops, like, hey, as long as they haven't entered quit, keep on going, because you're probably not going to sell something called quit or stop or I'm all done, or come up with anything you want for your sentinel value, right? It doesn't have to be quit. It can be, please stop this stupid program. I don't, sure, have fun with it, right? So that's the manage item mode here. So we're just going to make a bunch of items, as many as they want here, and then we'll enter their prices. Okay? In shop mode, ask the user to enter the name of an item to purchase. If the item has a file, add the cost of the item to a running total. And tell the user they bought it, or I don't know, they put it in their cart. I don't know. It's in their cart. Why not? Yep, so the manage item mode, right? They're going to go and set prices. Add item, set prices. In shop mode, they're going to say, hey, I want to buy this thing. And if there's a file, add that cost, right? You have to read the file, get the cost out, add it to that running total, put it in their cart. Allow them to purchase as many items as they want. Or I'm sorry, so if the file doesn't exist, that item is not for sale. Tell the user, right? Hey, if they want to buy banana and there is no banana file, tell them you can't buy a banana, right? This store doesn't sell it. Okay? Allow them to purchase as many items as you want. When they are done, right? Use some sentinel value. Display the total price of items purchased, ask for a credit card number, and pretend to charge them for it. Right, say, okay, here's your total, it's $329, please enter your credit card number. Great, thanks for purchasing things at our store. Right? And we're not actually doing any of this stuff. Right? Please, this is just pretend, we're just trying to be silly here. Okay? We also want to, no, that's fine. That's fine. We don't need to keep a shopping cart. Okay, so just two modes. You can manage items or you can shop. Right? Manage items will create all these files. Shop mode will go and try and read the files, see if the files exist, read them, get a total, and set some prices here. Okay, let me grab all of that. So I can write a rubric here. I'll grab this on the other screen. Oof, that's large, that's fine. We add a rubric. This is project 2. You either complete the objective or it's missing. Okay, yep, each item will have its own file. Yep. So, program 2 modes. Manage items, and shop. So you get a point just for asking them, hey, which one do you want to do? Having those 2 modes. So in manage item mode, user can enter the name of an item, and a file is created with that name. Enter the price of an item. The price is written to the item file. Okay, and then shop mode. User can enter the name of an item to purchase. Sure, we'll just do that. If the item exists, or the item file exists, add the price to the running total. If the item file does not exist, just tell them they can't buy it. And in shop mode, allow user to keep purchasing items till they want to check out. And in manage item mode, the user to continue creating items until they are done. Forgot to put that one up higher. So that needs to be up a couple more, right? So 3 points for manage item mode, right? They enter the name of the file, file is created, you enter the price, and you just keep on going until we're done. Yeah, definitely. I always try and put a rubric in to hopefully show you exactly where you get the points for doing what. So in shop mode, you can put the name of an item to purchase. If the file exists, you add the price. If it doesn't exist, you tell them they can't buy it. They keep on purchasing until they want to check out. And then shop mode, checkout. Checkout displays the total cost and asks for a credit card number to, I'm going to say quote charge here because sure, that's just silly. And shop mode can charge the user and display a confirmation number. How about a random confirmation number? There we go. This way we can actually use random as well, right? Use random class. Beautiful. There we go. I like it. A random confirmation number. We're using the random class. 10 points here. I like it. So worth just 2 more points than Project 1, so just a little bit more. Okay, and this overall score thing is silly. Overall score. Great. Okay, so 10 points for this one. Nope, 10. Oh, that's what happened. That's why my times got changed. 6 p.m. Okay. So do 6 p.m. in 2 weeks. Again, you are welcome to discuss this project with your study partner. You're welcome to discuss it in your supplemental instruction group. But if you are starting to take notes and write down what's happening, you're gone a little too far with that discussion. Okay, right? You're welcome to discuss and just talk about ideas. Perfectly fine. But if you're like writing things down or actually taking code, we've gone too far with that collaboration. Okay. We'll get to our group pair partner project at the end in our final project. But definitely feel free to ask questions. I definitely encourage you to post questions in the class Discord, because then if you're not sure about something, I can guarantee you someone else is also not sure about that same thing. And then they'll get to see your question and my answer, just as if we were actually in class and someone just shouted out a question out loud. Okay? Feel all right with this one? Again, it's a little bit. I mean, chapter 4 is big. There's a lot of stuff happening with loops and files, so we're going to practice all of it in the project. Mr. Gaddis has some great practice in the textbook. That's why you have a textbook, right? Go and read that. Look for more examples. Drop into my office hours if you have questions. Go to supplemental instruction groups. Book appointments with me if you can't make my regular hours, and we go from there. The goal is to get you to be successful at this. Okay, and I'll post a quiz for chapter 4 shortly. I should write myself a note here. Post chapter 4 quiz. There you go. Look at it, I got a note. Got the note. Okay, so this is officially week 4 here, so we're more than 20% of the way done. We've gone through 3 weeks. We're at 4 out of 15 now. This class just cruises, so please keep up and let me know if you're having trouble and what I can do to help. Okay, I'm here to help you learn it. That's what I consider my job here. Okay, because anybody can buy the book and read it. But having someone help you along with it, answer your questions, give you examples, that sort of thing, and give you projects too, of course, that always comes with it, because everyone likes that grade letter and numbers and things like that. It is academia, after all. Okay, questions, thoughts, concerns? Anything else for tonight? Are we feeling halfway decent about it? I mean, it might not be great, but that's okay, as long as we're, halfway there. All right, let's see who's around that we could pester. Are you folks actually into D&D, or is it just me? Or custom fabrication with Boyd, or rockets, rocketology? I think. Oh, he's playing Mech Warriors now. He's not actually doing his rockets. Or Neuro's playing World of Warcraft. That might be interesting. Or we can go watch some chess. Skylius is just chatting about comets, if you're interested in comets. We got all sorts of friends from the Knowledge Fellowship. We could go raid here. Some D&D? Alright, looks like Lantern Noir Is he playing or is he just prepping? I'm not sure. It's hard to tell. We'll head over that way and find out. Have some fun. He's a friend of mine. Alright folks, it's been fun. Let me know how I can help. I do have office hours tonight, 10 to 11 p.m. So hopefully I'll go for a run before too late, and I'll catch you folks later. Alright, everybody take care. Let me know how I can help.